freezing. I'm using OBS. It's free downloadable software. Nah, it's all good. It took me, I've been trying for like a couple hours and it's been a lot of like false starts and everything. But yeah, I'm using OBS right now. Okay. Yeah, multitask away, man. Okay, I'm gonna jump into, I think, the quiz just so people who are watching this later aren't like, oh my God, you guys spent all this time chatting. You think it's my Wi-Fi? Probably. Maybe I can figure out a way to plug my laptop into my internet and hardline in. The problem is my desktop doesn't have a camera, so I'm on my computer right now. I'm on my desktop right now. Is it freezing too much to work at all? Like, should I just like stop streaming and record the video and then upload it? Or do you want me to just keep going? My hotspot. I don't have a hotspot. What's wrong with you guys? I'm not that cool. What do you think? Should I start doing the math? Or no? Sorry. I'm sorry it's freezing too much. Yeah, okay, cool. Cool. Okay, let's get started. If you want to leave me comments or email me about how this is going for you, or if you want me to like try something else, let me know and I'll work on that. Okay, so question number 1. If you need to be doing this along with me, you should probably be grabbing some graph paper or something and write everything down on. But question number 1 is probably one of the questions that I saw most people kind of really struggle with, because this isn't just like a solve the equation thing. So we've got y equals 3x plus 1, and we've got this equation x plus 3y equals -7. So I'm just copying this down right now. And then the neat thing about this one is we're not being asked to like find the solution, we're being asked to pick the solution. So we've got this choice A of 1, 4, B, which is -1, 2, or -2, and C, which is 10, -1. Okay, so you should be thinking to yourself, like, for each of these, the question is like, is this point a solution up here, right? So the questions are which point, but really like what you should be thinking about is like, is this a solution? And so we can check that, right? Like if it's a solution, and that means if I plug in 1 for x and 4 for y, then the left-hand side and the right-hand side would be equal. And maybe you're already like doing this in your head, but let me kind of show you what I mean by plugging this one into here. So this says like y equals 3x plus 1, but I'm replacing 1 with x and 4 with y. So y becomes 4, 3 times 1 plus 1. And then 3 times 1 plus 1 is in fact equal to 4. So we say this point works for the top equation, which might make you think A is the right answer, but it's not. And the reason it's not is because we need to check x being 1 and y being 4 into the second equation as well. And when we do that, we're going to be unhappy. You guys already see what's going to happen. So when I plug in 1 for x, becomes a 1. When I plug in 4 for the y up here, 4 for the y right here, this becomes 3 times 4. And I'm just going to copy the -7, but this is not going to work out, right? This is 1 plus 12 equals -7. Boop, this is not true. So this tells you that this point, even though it works for one, it doesn't work for the other. So this one is not an answer. Okay. Do you want me to do the other ones? Can you go to the bathroom? Yeah, make sure to take a pass. Do you guys want me to show what happens for these two, or do you think you can like figure that out on your own? Was this like a good enough example for what to do? Kind of waiting for you guys to respond in chat. I'll take a sip of tea really quick. I'm not seeing anyone respond either way. So maybe I'll like set up B and C, but I won't actually like run through the details. So it's the same thing, right? Y equals 3x plus 1, but now I'm plugging in -1 and -2 in for x and y. So this becomes -2 equals 3, -1 plus 1. And then now, like, I'm not finishing this, right? Then you guys need to go back and check, like, is this true or false, right? True, false, right? And then you have to do it for the other one as well, right? If you have x plus 3y equals -7, again, plug in -1 for the x, plug in -2 for the y. 3, -2 equals -7. You have to check, right? True or false. And if it's true for both, then that's the right answer. If it's not true for even one of them, then you would have to go and check C and do the same thing. Yeah. Is that good? Can I get like a quick check-in? Can I move on to the next one? Or do you want me to pause for a second? The reason I keep looking over here is because this is where I'm looking at chat. And you guys are doing really good with this chat. It's really helpful for me to like see what you guys are writing and like checking in, and even the other stuff is like still useful. Like, thanks for the jokes. I'm glad everyone's keeping a good sense of humor about all of this. Please feel free to eat in class, go to the bathroom when you need to, anything like that. I guess I guess you're probably all on your phones. I'm curious, how many people are doing this on their phones versus how many people are like doing this on like a computer or a laptop? Because that would be helpful for me. All right, it looks like we're gonna move on to number 2, and number 2 is like really quick. So let me scroll down. Number 2. Number 2. I don't even know if I'm like writing anything down here, right? I guess 2, just the big idea is, the question is, what is the solution to the system of equations? And the thing to remember, like the big idea here is that, and this is kind of what we're thinking, is that solutions are the intersections. Right, so if you see an intersection in the graph, which we do, right, then we know that the point of that intersection is the solution. And so counting over, this is hard to do. I guess I'll use the mouse. So counting over to get to this point, we would go over 1 and up 1. So then we say like the intersection is at the point 1, 1. Right? And literally for this problem, I know I gave you like this big white area for this solution, but like this is the answer. Oh, are we switching to Japanese? My Japanese isn't that good. My Japanese isn't that good. I don't know what you're saying. I hope it's appropriate. Something. I don't know. So that's it. This is number 2. Right? The solution is wherever they intersect. The intersection's at 1, 1. And there we go. A lot of people, when they were taking this test, like said that they got stuck on number 2 or they weren't sure what to do. And I understand that. Like, if you're not quite sure what's being asked, that's fine. My advice when they did that, though, was to actually go on to number 3. because number 3 essentially asks like the same idea, but in the other direction. So number 3, I'm going to keep moving down on my paper, asks to like draw a graph of something that has no solutions, right? No solutions. So like, let's think about that. Let's do some thinking. So if number 2, the whole idea was that solutions are intersections, but now we want to have like no solutions, then what does that mean? How do I draw 2 lines that have no solutions? And like, if this wasn't live, I would probably tell you to like pause the video and think about that, and then maybe try this out for yourself, right? How do you draw something that is 2 lines but has no solutions to it? They're both horizontal. So horizontal means like they look like this, right? And so here, I can't draw over this, but I'm going to use my Oakland library card to draw straight lines. So one idea is like, well, maybe they could both be horizontal. So scoop and scoop. Okay. So like if I have these 2 lines, are they going to intersect? No, they're not. They're both horizontal. So this works, right? If you were to take these 2 lines and like draw them like over here, over here, then that would work, right? Horizontal. But this isn't the only version that works, right? They don't have to look like this. What's special about this is not only that they're both horizontal, but that they're both going the same direction, right? So I saw some other people say something, and I won't give it away just yet, because hopefully other people, well, I guess everyone in chat has already seen it. So like something like this would work as well. But the thing that like this example and this example both have in common is that they're both parallel to each other. And that's kind of the key idea here. So I saw that in chat. Nice job. So like, as long as you're drawing parallel lines, you're drawing something that doesn't intersect. And that's kind of what I would put in this thought bubble. So like no solutions is when the lines are parallel. Just do the YouTube videos and then put it on. Would that make me like a great teacher or just like the worst teacher? Like admin would just come in and I'd be sitting in the back of the classroom and you would just be watching videos? Sure, maybe. We'll see. If we ever come back to class. No, I'm just kidding. We'll totally be back. Pizza party for everyone. 1 million subs. Totally. All right. Are we good with number 3? Can I move on? I was hoping to be able to get through this whole thing in like 30 minutes tops. Maybe less if that works out. I'm waiting for some responses from chat. Are you ready to move on or not? I'm asking also because I'm running out of space at the bottom of this page, so I'm gonna have to like flip the page, and I want to make sure you guys are ready. Cool. All right. So I'm gonna flip page. Moving back to the top of my notebook. And now we're on to section 2. So this is question number 4. All right, solve the system of equations using graphing. So we have y equals 1/2 x minus 4. Now, if you guys are using like a printout of the quiz, like if you're able to print it out, obviously you don't need to be writing this down along with me. But if you're doing this by hand, you do want to be writing out the equations that we're going to be graphing plus 7. And what I'm going to do is I'm going to make myself a XY axis to graph on using my Oakland library card because I forgot to take 2, 3, 4, 5, 6, 7. I forgot to take my rulers home with me. So I just like pulled this out of my pocket. Represent Oakland, you know? All right, x-axis, y-axis. All right, we've done graphing so many times, it's like it's really important or something. So I'll graph this one in blue, and then I'll graph the other one in red. Okay, I want everyone to hold up their thumbs if they're good with graphing. Okay, good, good, good. I see a few people with their thumbs up. Great. Okay. Good thing we're doing this on video so you can go back and watch it again. Let's do the blue one now. So the blue one, remember, there's two things we need to know when we're graphing anything. One is the y-intercept, which in this case comes from the -4. And the other thing we need to know is the slope, and it comes from the 1/2 in front. 1/2. So to graph this, the y-intercept tells us to start by going down to -4. 1, 2, 3, 4. Oop, at the very bottom of my graph. And then the slope 1/2. Remember, this is vertical or rise. Should I shift over a little more? And this is horizontal, also known as run. So -4, and then up 1/2 gets me to there. And then I will, maybe I'll do it one more time just so I can make sure my line's really clean. So up 1/2 again, right there. And blue line. So there's one line. I left all my pencils at school too. Literally the only pencil in my house is like this mechanical pencil, but it'll work. It'll work. All right, second line. Y-intercept comes from the +7. So my y, oh, should I wait for you guys? So just if we're just labeling, if we're not graphing it, I'm going to be writing down the y-intercept and the slope, right? So check for yourselves. Looking at this equation, do you know what I'm going to write here? Do you know what I'm going to write here? Do you? We're getting a little off topic in the chat. Why? How did we get on Ice Ice Baby? Is this a Vanilla Ice reference that I'm not familiar with? I'm scrolling back up. Amazing. Excellent. Excellent. I see that. Oh my God, now we're even responding mathematically in chat. If that's who I think it is, I'm gonna give you extra credit. Keep track of your Aries. That. Today is a good day now. Today is a good day. That was great. The slope, so if you're thinking the slope is -3, I'm actually gonna write the slope down a little differently because I want to have this like fraction to reference again. So I'm not only going to write -3, I'm actually going to write -3/1. And again, remember, this is my vertical motion, and this is my horizontal motion. And I'm just doing the one to remind myself how much I'm going left or right. Okay, so y-intercept, like you said, is 7. 1, 2, 3, 4, 5, 6, 7. So that's my first point. And then my slope is -3/1. So the -3 tells me I'm going to go down 3 and over 1 from my y-intercept. So 1, 2, 3 over 1. And let me do it again. 1, 2, 3 over 1. And I'm only doing like the second line so that when I connect the dots with my Oakland library card, I get a clean line all the way down. Did I make a mistake? 1, 2, 3, 4, 5, 6, 7, 3, 1, 1, 2, 3, 1. Yeah, that's good. Okay. Okay. And so it looks like I'm getting some like rounding error, but the solution of this problem is going to be the point again where they intersect. And so we got to figure out, oh, I missed some stuff in the chat because I was graphing. So we got to figure out where this point is. So counting over 1, 2, 3 and a bit, and it's like 1, 2.5. So for this one, it looks like the intersection isn't a whole number, which honestly doesn't really bother us because we're just graphing. But so I would say this is about at 3 and then comma 1, 2 and negative 2.5, something like that. Doing this now, I'm a little weirded out because I thought that the answer should have been on a lattice point. So I'm going to go back and look at this and see if I made a mistake here, but I think that's right. Does anyone catch a mistake here? Yeah. The one thing to notice though, and like this is the mistake I see the most, is people are like so amped about graphing the lines, they graph the lines and then move on to the next problem. Remember, the answer to the problem is actually naming and labeling like this point of intersection, right? If you didn't write down these coordinates, you did not finish the problem. So do make sure that you go back and actually identify like that point of intersection is the solution. Yeah. Even the wisest of us makes mistakes. That's some wordy wisdom right there. All right, I'm going to go on to number 5 because it's kind of like a follow-up of this question. And number 5 says, explain how we know the system of equations above has only one solution. So I'm going to continue to like think about these like thought bubbles, right? So if we want one solution, what does that tell us about the lines, right? If we want one solution, what should the lines look like? When we say, well, the solution, when there were no solutions, let me flip back, right? When there were no solutions, the lines were parallel because they didn't intersect. Then if we want one solution, then that means we need one intersection. Is that what's happening here? Or is that what's happening here? Yeah, so explain how do we know this only has one solution? Well, you can say this however you want, but it's something like the lines only intersect. Ooh, that's bad handwriting. Do I have an eraser? The lines only intersect one time. Something like that. Sound good? Chat's getting silent. Did I lose everyone on that one? Ooh, because it's not curved, right? So yeah, so let's unpack what I didn't say here, right? So I said lines, which means we're thinking about things like, oh, well, lines have to be straight, right? So straight lines mean like no matter if I keep going in this direction and I keep going in this direction, there's never going to be some kind of like wavy, like, woo, right? These never going to like come back and cross again. Like that's never going to happen because then they wouldn't be straight lines, right? So straight lines can only intersect one time, right? If they intersect at all, because we've looked at situations where they don't even intersect. So straight lines can only intersect one time. They're never going to intersect twice or 3 times or 4 times. Cool, 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 cool. All right, is that good? Yeah. So I'm going to take a quick tea break. And then are we ready to move on to the next section? All right. Did I make a spelling mistake? It does say insect. Amazing. I just wrote the same thing again because it was on my mind. Intersect? Good catch. Glad you're paying attention. Oh, nice, nice. As always, mistakes I make are by accident, never on purpose. I'm glad you guys are paying attention. But honest mistakes happen to all of us. All right, let's move on. Now I'm getting some bleed through. That's fine. All right, number 6. So number 6 is like one of the really, I don't know, long problems because now we're being asked to use substitution. So 3x plus 4y equals 21 and y equals 2x minus 3. It's possible for one to make a mistake on purpose. No, but my point is like I'm not doing this to like trick you or to see if anyone is catching it. Like I'm not intentionally seeding wrong answers in here just to see if people are paying attention. That's what I mean by mistakes. All right, so in this one, since we're using substitution, the key is to realize that in the beginning, we are being told that y is equal to this. And then we need to realize that we see a 4y up here. So when we talk about substitution, since we have like this y right here, and we know that that y is equal to 2x minus 3, then we know we are going to substitute the 2x minus 3 into that y up there. Right. So, and like, remember, what are all those synonyms? Like when we say substitution, like used elimination for the substitution problems. That's all right. That's good. What are those synonyms for substitution? Like if we say substitute, what are the other words that we tend to see? Right. I promise you, you're going to hear me say something like instead of. Right. You'll also hear me say things like plug in. And usually when we plugging in, we're only plugging in one number. Yeah, but in this case, we're not plugging in a number. We're plugging in this whole thing, this whole 2x minus 3. You also see words like, what's the other one? Oh, replace. That's the one I'm missing. Yeah. So we're going to, replace the y by plugging in 2x plus or 2x minus 3 instead of writing a y, right? All of this is the same. All right, so let's see what that looks like. So 3x, so I'm going to take this up here and I'm just going to copy it down there. So I'm going to write 3x plus 4, right? This 4 is that 4. But now, instead of y, I'm going to write something else, equals 21, right? And no surprise, what goes in here? 2x minus 3. Cool. So I think I haven't done it yet, but I'm gonna make a video. I'm gonna make a video on distributing again. But that's something you can like. Maybe I don't know. Maybe I'll like link a video. There's so many distributing videos online. The goal right now is for you to be able to rewatch it when it's over. Yes, I'm also recording this, so you should be able to watch it again. But for right now, when we distribute the 4, I'll just remind you that we distribute the 4 to the 2x, and we distribute the 4 to the negative 3. So I'm going to pause here and look at chat because I want you guys, like, for those of you who are comfortable with what happens next, I want you to practice that right now. So when I distribute the 4 to the 2x and the 4 to the minus 3, like, what's actually going to happen here? And then I'll copy down the 21 over to the other side. So another tea break. Oh yeah, it looks like Streamlabs really doesn't like the Japanese. Is that what's still happening? I know it's cutting you off if you're using Japanese a lot. Is the slurping bad? I don't know. I'm getting a lot of feedback on slurping. The tea does taste really good though. Okay, cool. All right, so distributing the 4. So this is distributing using multiplication, right? So it's 4 times 2x, which is 4 times 2, 8x. And then 4 times negative 3, 4 times negative 3 is negative 12. Right? That's amazing. If you're not sure how to do this, write me later and tell me specifically like what's going on here that you want extra like feedback or what you want extra help on. Is it the distributing, like 4 times 2 is 8, but there's an x there, or 4 times negative 3 is 12, but there's a minus sign there? Like I said, I'm going to do another distributing video later. So keep your eye out for that if that's the part that was bothering you. All right, next step in this substitution is the 3x and the 8x are like terms. If I have 3x and I'm adding 8 more to it, then I get a total of 11 of those x's. Minus 12 equals 21. Do you want me to annotate? Like, let's annotate what's going on the side. So this step right here was distributing. And then what I just did now, this was combining like terms. Maybe I'm kind of off the page a little bit. There we go. Combining like terms. Only with distributing? Okay. But now, like, here's the other thing. Like, this is a long problem. We're only like halfway through this problem. And I know I'm like taking pauses and breaks and everything, but like, there's this distributing step, there's this combining like term step, and now we have to like solve this problem. And this is that standard inverse operations process. So the negative 12 needs to get canceled. So I add 12 to both sides. 21 plus 12 is 33. The 12 and the minus 12 cancel, which leaves me with an 11x. And then to get rid of the 11, we have to divide and divide. So the 11 reduces, and the 33 over 11 becomes 3. Right? So this, what we just did here, the canceling the 12 and the dividing by 11, this is, we're solving, right? We're solving for x. And people also say like isolate x. You can use your phone during class. The best part about quarantining is you can use your phone right now. And I don't have to feel bad about not yelling you for it or yelling at you for it. Either way, we can just get it done. Okay. So this is x. Question, are we done with this problem? I'm not saying anyone answered the question yet. Maybe we're done? If anyone's trying to answer in all caps, that's why it's not working, because I made my chat restrictions really, really high just because I wasn't sure what to expect from today. Okay, good. Are we done? Is this problem over? Now that I know that x is equal to 3? I'll give you a hint. Yeah, not done yet. Not done yet. Because even though we know x is 3, in systems, there's always an x and a y, right? I could flip back, but I'm not going to because I think you see it right here, right? Remember, this whole problem started by saying y is 2x minus 3. We're not done until we actually complete that. So now we're going to use this equation, and y equals 2x minus 3. But remember, what do we know about the x now, right? We know x is 3, so we can again substitute, right? Replace x with 3. Yeah, good, find y. So I'm going to do that. So here we have this x value, and we can now write y is equal to 2, 3 minus 3. Okay, what's 2 times 3? 6 minus 3. And then 6 minus 3 is 3. Okay. If you've got these, you should feel like you're good, but just as a reminder, in our class, we've been really kind of consistent about giving our answers in this format, right, coordinate format. So the final answer for that problem is, yeah, nice. I'm seeing some people say 3, seeing a lot of you say find y. Good job, nice job. So we got 3, 3 here. Dope. Yeah. Nice, 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 nice. Cool. So like this substitution problem, right? This is a substitution problem, but understand like all of these like hidden skills or like skills that go into this problem. There's the distributing step, which is like not something we've talked a lot about, but it's really important. And then there's the combining like terms step, which when we did it, everyone was like pretty good at it, but we haven't really talked about combining like terms recently. And then the solving for x, which I know everyone is like getting a lot better at. But remember, like now the solving for x is just like one part in a much longer problem, right? Okay, can I move on to number 7? Now I'm like really self-conscious about the tea drinking, but. All right, let's move on. 7. Okay, oops, 7. All right, Alex is trying to solve this problem using elimination. Help them out. X equals 7y, or x plus, 7y equals -9, and 3x plus 7y equals 1. I know, I'm really self-conscious about it. I slipped a little bit. Okay, in this problem, I'm reading A. In this problem, they should add or subtract the equations because doing that will eliminate the blank. So when I look at this problem, there's something that really, like, to answer this problem, to realize why we're using elimination, there's something you have to notice. And if you don't notice this, it's not going to make any sense, right? You're not going to see what you need to see. And the thing you've got to notice, should I use red? I'm going to use red because it's a really big deal. The thing you have to notice is that this 7y is in both of them. And so immediately we think to ourselves, aha, these might cancel. Right? And so the question though is like, if I add them together, 7y plus 7y becomes 14. But if I do 7y minus 7y, then they will cancel. And so the answer to this, the part A, right? In this problem, we should subtract the equations because doing that will eliminate the y's. And I've already looked at a lot of people who've already taken this quiz. And a lot of people, instead of writing y values, they wrote 7y. And I thought that made a lot of sense. Like this was really helpful for me to see, like it's really clear that you're doing it on the 7, or you realize it's the 7 y's that are being canceled. Okay, so part B, Alex started doing it on their own, but then got distracted. Help Alex finish the problem. So we've got our x plus 7y equals -9. And we know that for this to work, we need to subtract the second equation. So we're subtracting the 3x plus 7, or 3x plus 7y, sorry, 7y. And we're subtracting the -1 from the other side. And like, double check with what just happened here. I don't know why I just got signed out. That's okay, right? The 1 is getting subtracted from the right-hand side, and the 3x plus 7 is getting subtracted from the left-hand side. Do I need to sign back in? What's going on here? Oh, you guys are going to see my password. Now you're all going to be able to steal my OUSD login. So the -9 and -1 become -10. When I subtract here, remember I'm subtracting each of these. So x minus 3x is -2x. And the 7y minus the 7y, this is what makes them cancel. And I'm going to pause there because that wasn't like, do you want me to like explain that more, or is everyone cool with that? So the thought process behind this individually, the x and the 3x, this is x minus 3x is -2. So that was my thought for the x's. And then this is 7y minus 7y, and that's what gets me that nothing. And then it's -9 minus 1, and that's where the -10 comes from. So like piece by piece. Right. Oops. And now we solve for x. So divide by -2, divide by -2. Now, if you're watching my videos today, I talked a lot about negative signs, two negatives. -10 divided by -2 becomes +5. So that's my x. Explain? Okay. Before I do that, let me finish this out. So since I found x, I still have to find y, and I'm going to do that by taking one of these equations and plugging what I know back in. So let me do that over here. So this was 3x plus 7y equals 1. But I know that my x is equal to 5. So this becomes 3 times 5 plus 7y equals 1. 3 times 5 is 15. Okay, then I subtract 15 from both sides. 7y, 1 minus 15 is -14. And then divide by 7, divide by 7. I'm at the very bottom of the page. Y equals -2. So then my final answer is 5, -2. And I know I did this part quickly, but we've already done some solving for x and solving for y, so I don't mind kind of leaving this up here for you guys to go through, but then going back quickly. Is that a 3 or a 5? That's a 3, that's a 3, that's a 5, that's a 15, that's a 5, that's a -2. This is an x, this is a -3x, this is a -2x. This is 3 parentheses 5, yeah. So for the elimination stuff, so let me go through this kind of piece by piece. In the original equation, did you guys see that it's a positive 3x plus 7y equals a positive 1? But since we are subtracting, when we actually do it over here, this positive 3x is being subtracted. The positive 7y is being subtracted, and the positive 1 is being subtracted. So that's why you see all these negative signs here, because when we're actually combining the equations, we're subtracting the 3x, we're subtracting the 7y, and we're subtracting the 1. And that's, now if you want to go further back, why are we subtracting? Well, it's because of here, right? We wanted the positive 7y that we saw here and the positive 7y we saw here to cancel. But that only works if we subtract one of them. I'm going to move on to the last problem. But if you are still stuck or you still want to get through this elimination stuff, text me or write me a comment, and I will make sure to go back and do that. I must see the other equation stuff. Sure. There. Tea break. Hey, puppy. How you doing, doggy? Okay. Can we move on to the last problem? Waiting for confirmation. You want to see the doggy? All right, let's see if I can get him up here. Hey, buddy, come here, sit. This is my doggy. He's not very big. He doesn't like sitting on people's laps, but this is his face. Say hi, buddy. You're gonna be internet famous, like you always knew you should be. Yo, buddy. No feet on the table though. Okay. Oh, buddy. Okay, buddy, you gotta go. Go, buddy. All right, moving on. Can you have it? No, you can't have my dog. You're crazy. I can't have my dog. Set this up for the last page. Yeah, I wasn't sure if I was going to show you the dog or not, because I knew the dog would become more popular than I was immediately. But whatever. All right, number 8. X plus y equals 7. Don't threaten to kidnap my dog. It's not nice. 4x minus 18. All right, last problem. So number 8, Alex is solving this other system of equations. They have figured out that x equals 5. Number 1, or part A, what does Alex need to do before they are finished? So this has actually like come up multiple times on this test already, right? So this is just, quizzing us on like, okay, when someone asks me the question straight up, do I actually remember what I still need to do? I'm not solving it, right? If I know x is equal to 5, what do I still need to do before I'm done with this problem? Yeah, I always use my name, so other people don't feel like they're being called out. I need to do math? Yep, 100% true. There it is. Okay, cool. Right, so the thing we're missing here, if I know x is 5, like right now you should be thinking like solution means, right, being able to fill in the points. But to do that, you still need to know the y value, right? So the thing that we don't know is that y value. So solve for y. Cool. All right. B. Use the fact that Alex knows x equals 5 to complete the solution. So if we need to solve for y, how do we use how is x equal to 5? This was given. So when I wrote this problem, I made sure that the correct answer was that x was 5. But for this problem, I'm not telling you how you should get that. Like if someone kind of showed up and said, hey, I know x is 5. Finish the problem for me, right? I did the first half, you do the second half kind of thing. So for this one, we're taking it on faith. But if you want to double check this later, we could double check to make sure that x being equal to 5 actually is the correct thing to do. And I'll show you that. So how do we do this? If I know x is equal to 5, well, we can use our equation again and say x plus y is equal to 7. Because we know 5 and x are the same, we can substitute 5 in for this x over here. 5 plus y equals 7. And so to find y, and this is the kind of thing, like when we do this, a lot of people at this point are like, I don't need to use inverse operations. I can just look at this and be like, obviously, if it's 5 plus something is equal to 7, that something has to be a 2. And if that's the way like you're thinking about doing these problems, that is totally okay, right? So at this point, if you just want to say like, obviously, y has to be equal to 2, that's totally fine. If you were to solve it the other way, you would be subtracting 5 from each side. So the 5 minus 5 cancels, 7 minus 5 is 2. You like my annotations? So then we know 2 is their final answer, right? So up here, I'm going to put 2 for y. Now, the question that got asked was like, wait, how do I know x is equal to 5? And kind of the short answer is, well, I told you. But what we could do is take this information and make sure it actually works in the second equation as well. So this is optional stuff right now, but maybe good practice. So we say y is equal to 4x minus 18, and we think the solution is 5, 2. And if the solution is really 5, 2, then we should be able to take the 5 and plug it in for x, and take the 2 and plug it in for y. So 2 equals 4 times 5 minus 18. Is this true? Yes, right? So when someone says like, hey, wait, how do you know x is equal to 5? And because I told you isn't a good enough reason, this is how you would know that whoever told you x was equal to 5 knew what they were talking about, right? Because it worked in this equation, and it works in the other equation as well. 5 plus 2 equals 7. Okay, that was it. I'm not going to include the extra credit in this video because it's already going really, like this video is already going pretty long. It's an hour, which I think feels fine in terms of like this chat. But when I upload this, I don't want people to have to sift through more than an hour-long video if they don't have to. So if you want to see the extra credit, I am going to ask you to like let me know. I'm more than happy to upload an extra credit video for this problem here if that's interesting to you guys. But if it doesn't seem like there's a lot of enthusiasm for that, then I probably will do something else with my time and make videos on other stuff. So yeah, this is it. I think when I upload this video, I'm probably going to cut it right now. So thanks for watching, guys. Make sure that you upload your work onto Google Classroom when you are done filling out your own quiz number 3. I will also encourage you to not just go through and copy down all of these answers, because this is really meant to be a review if you get stuck or if you are not sure if you got the right answer. But remember, this is all required to be done or submitted by the time you come back. So I will see you guys whenever you come back. Make sure to take care of yourselves and each other. Bye. All right, that was for the YouTubers. Are there things in chat that I need to respond to? How are we doing? My hat? My beard. This is getting really personal. Oh yeah, I need to work on my like YouTube sign-offs. Make sure to like, comment, and subscribe. I gotta remember that. Should I try and get some sponsorships? Should I try to get Raid Shadow Legends to sponsor me? That's good. Yeah, yeah. All right, so that's the video, right? Are there other things that you guys want me to like talk about, math related stuff? I'm more than happy to like stay up here and just like chill out with you guys. I've never seen my baby face. Yeah, no, I haven't had a shaved face in a long time. It's been a couple years. A couple years. So, yeah. I don't know. What else can we do? Do you guys want to see the thing that I'm trying to make with